Refer problem number 24. So this is based upon electrochemistry and all electrochemical cells, that is a cell in which the current is produced, that is called galvanic cell. We have two compartments, one is oxidation compartment, another reduction compartment. If these two reactions are combined, we can draw what's called electricity. When electron flow, that constitutes current. And here we have zinc electrode and copper electrode. And zinc electrode, standard electrode potential minus 0.76 volt. For copper electrode is plus 0.34 volt. And here first standard EMF of the cell we have to calculate. So this is calculated by the formula. So this standard EMF of the cell is equal to, so standard electrode potential of cathode minus standard electrode potential of anode. So E cathode minus E anode. Now zinc and copper, which one acts as anode, which one acts as cathode? That electrode having lesser electrode potential will act as anode, and higher electrode potential, I mean the electrode having higher electrode potential will act as cathode. So cathode minus anode, now higher value for copper, that is plus 0.34 volt minus again minus 0.76 volt. That will give plus 0.34 plus 0.76, that is equal to 1.10 volt. So E cell, standard EMF of the cell, this is equal to 1.10 volt. So one first question is answered. Therefore we can write here, so E standard EMF of the cell is equal to 1.10 volt. So that is correct. Next, del G, this is the Gibbs energy change, standard free energy change, or we can call it as standard Gibbs energy change. Del G naught is equal to minus NF E naught. This is the number of moles of electrons in the cell reaction and Faraday constant, and this is the standard EMF we have just found out. For this cell is concerned, that minus 2, N value is equal to 2, and Faraday constant 96,500 coulomb per mole, and EMF is equal to 1.10 volt. So all if you multiply, we have minus 212,300. So we have this much joule will come. Normally free energy change is expressed in kilojoule per mole. Therefore del G naught must be equal to minus 212.3 kilojoule per mole. So this is also the second answer. So standard EMF calculated, and also free energy change. Next, one more thing is equilibrium constant. For the calculation of equilibrium constant, so we have to use the formula, that is log equilibrium constant is equal to N E naught by 0.0591. So this will 2.303 RT by F, and at 298 Kelvin the reduced form will give this answer, because since we are dealing with the standard state, so this will be a constant. And in Daniell cell, this is a Daniell cell, here N value is equal to 2. So if you substitute 2 into 1.10 divided by 0.0591, so here this will give the answer approximately 37. So log K is equal to 37, and if you want to calculate the equilibrium constant, you must take the anti-log of 37. So that must be equal to 10 power 37. So all the three questions are answered. That is standard EMF 1.10 volt, and free energy change, that is standard Gibbs energy change minus 212.3 kilojoule per mole, and finally the equilibrium constant is 10 power 37.